But now we know how rocks are broken down into smaller pieces of sediment through weathering. The next few videos are going to focus on sedimentary rocks, the rocks that are made out of that sediment. We'll see that sedimentary rocks form from weathering, from breaking down pre-existing rock pieces, and then transporting and depositing those rock pieces, known as sediment, somewhere else. And we're going to see that most sedimentary rocks form from lithification, where we're basically going to glue each piece of sediment together as a solid sedimentary rock. And sedimentary rocks only make up about 5% when we're looking at the entire Earth. But they make up about 75% of the surface. So they're some of the most common rocks that we can see up here where we live. And while sedimentary rocks don't make up a large percentage of the Earth, they give us a lot of really important details about the Earth's past history. And this is because these are the type of rocks that we find fossils inside of. But sedimentary rocks are also really economically important. This is where we find our fossil fuels, like coal and oil. We also find our metals and our rare earth elements that make our electronics. We also use it for fertilizer and our different forms of construction, for buildings and roads. But we're going to be able to break sedimentary rocks into 3 textures or groups based on how they form. The first is called clastic or detrital sedimentary rocks. And these form from pre-existing rock pieces that have been weathered down and then cemented together as a new rock. So these clastic sedimentary rocks are just a bunch of pre-existing rock pieces, like we see in the upper left. But the second type of sedimentary rocks are called chemical sedimentary rocks. And these form where the sediments are so small they're capable of being dissolved inside of water. But over time they're going to be just too much stuff dissolved inside of the water. So it's going to settle out towards the bottom in a process that's called precipitation. And it sounds a little weird, but we'll get more into it in a couple of slides. But chemical sedimentary rocks form from precipitation of dissolved sediments to the bottom, forming solid rock out of water. And then our third type of sedimentary rock is called an organic sedimentary rock. And these are the ones made from organic bits, or some form of organism, whether it was a plant or animal remain, which we can see here in the bottom image with all of these seashells. But to get into each of these 3 just a little bit more, we're going to start off with our clastic sedimentary rocks. And again, these are the ones made up of pre-existing rock pieces that were weathered down and then transported somewhere else to be deposited. So they contain a lot of different types of rocks and minerals inside of them. So when we're looking at these clastic sedimentary rocks, to tell them apart, we want to look at things like the size of the sediment pieces within the rock. This is going to tell us a lot about how much energy was in the environment, as well as how it could have been deposited, whether it was deposited by wind or water or gravity. But when we're looking at lithification, when we're causing all of those loose pieces to suddenly be a solid singular piece, it's going to happen through lithification, which generally has 2 processes that happen. The first is compaction, and the second one is cementation. So compaction just happens when we start compacting all of these different pieces of sediment together. Some kind of pressure or weight is trying to force them all into a smaller area. And generally, this is most significant in our fine-grained or our small rocks. But before we can turn that sediment into solid rock, after we compact it, it also has to have cementation occur, where each individual loose sediment is going to be cemented to the next piece. Overall, it's going to form one solid rock. So to do this, we're going to have generally some form of water with a lot of dissolved substances inside of it flowing through the sediment, and it's going to precipitate or glue each piece together. And we're going to see that cementation is going to be more important for our coarse-grained rocks than our fine-grained sedimentary rocks. So we're going to be able to break each of these clastic sedimentary rocks down and name them based on the size of the sediment particles inside of them. So starting off with the larger ones, we're going to have gravel-sized particles. So these, just think about like a pebble parking lot or a pebble road. We're going to have two different types of pebble size or gravel sized clastic sedimentary rocks, which are called conglomerate and breccia. And while the size of their sediments are the same, the difference is how round or how jagged those sediments are. When we look at conglomerate, it has rounded sediments inside of the rock, whereas breccia has really jagged, kind of edgy pieces. So both of them have the same size, but they tell us different things about the background based on their angle. The conglomerate has traveled farther as sediment before it was deposited than the breccia had, because when it travels farther, the sediment pieces will get more rounded over time. But if we look at particles that are smaller than gravel or pebbles, we look at sand-sized particles found here in the middle. And here, they're all sand-sized particles, so we call these sandstones. When you rub them with your hand, they're going to feel exactly like sandpaper. But sediments can get even smaller than sand size. So if we're looking at mud-sized particles at the very bottom here, we can have shale or siltstone. So siltstone is very fine, but shale is like very, very fine clay particles. So with each of these, whether we're looking at gravel, sand, or mud, we're going to be able to give this sedimentary rock a very specific name.